Alright guys, so we're gonna get started today, and I was gonna have some snazzy Steelers wheels stuck in the middle with you playing for you, but apparently it doesn't work so well through a speaker to microphone connection. So one of these days I'm sure I'll get techie enough to make that work. But today's lesson is entitled "Stuck in the Middle with You." You should be on the ionic bonding page. We kind of work through how to build atoms, how they're gonna bond when they transfer ions a little bit. And so to get kind of talking, we need to back up and look at what we did today in class, which was a quickie review over read the periodic table and how atoms are set up and what they look like. So yesterday we learned that we can read the periodic table, and on the periodic table we get some basic information. Number one, the atomic number is the number of protons, okay, and that's going to be equal to for a neutral atom the number of electrons. Below that you have the number of or the chemical symbol, and below that you have the atomic mass. Chemical names also in there, and then from the atomic mass you can approximate a decent mass number for a reasonable number of isotopes or atoms of an isotope. And then down here we have a little model of how an atom would look drawn in the Bohr model method. So you have in the middle, you have your protons and neutrons, that's where they go. Electrons go in the rings around them. And remember, we know from the octet rule that there's a formula we can use, 2n squared, to figure out how many electrons should go in each level. And so that first level, you get 2 electrons. First orbital, 1 squared is 1 times 2. Second level, you can have up to 8. And so that's going to become important in how we look at things bonding. But the first step to that is looking at drawing. So to draw an atom, first step, we're going to draw a nucleus. So here's your nucleus in the bottom. Second step is to fill in the number of protons and the number of neutrons. So we're going to use hydrogen as our example. And so hydrogen has 1 proton and 0 neutrons. Remember, because the atomic mass of hydrogen is 1.00794. We round that to the nearest whole number is 1. And so we know that the mass number for many hydrogen atoms is going to be 1. And so neutrons is going to be equal to your mass number minus protons. So 1 minus 1 gives you 0 neutrons. So we have our nucleus kind of set up here. And if you really wanted to get artistic, you could put individual subatomic particles there. But numbers will work for what we need to do. Then you need to draw in your energy levels. And these are going to be the orbits that the electrons are going to go on. And then you can fill in electrons for how many electrons you have. Hydrogen has 1 electron, and so you get 1 circle. And so this would be what an atom of hydrogen would look like if we were to draw it out. Okay, and we can do that with any number of atoms. So over here, we've got one drawn out for, it looks like lithium, 3 protons, 4 neutrons. Since there's 3 electrons, the first energy shell can fit 2, so we put 2 circles in that first energy level, and then I need a third or a second energy level to fit that third electron in, and so it goes up there. Over here, I've got, is that 2, 10, 11, so it's going to be sodium. And so over here I should have, this actually should say 11 protons and 12 neutrons. And so if I have 11 protons, it tells me I have 11 electrons. Up to 2 can fit in the first shell. That leaves me 9 left over. I can fit up to 8 in the second shell. So that leaves me 1 left over. So that 1's going to go to the third shell. And so this is how we draw the atoms out. If I get really big atoms, some of the things like gold or mercury, even up to silver and things where I have 30, 40, 100 different circles that I would have to draw if I'm doing electrons. At that point, what we can do is we can just say, okay, I'm really not going to worry too much about putting all these circles in. I'm just going to do numbers. So you can kind of lop off the back side of the circle, slide the atom over in your space to draw it, and just put numbers in. So I would just put a 2 here, an 8, and then a 1. Okay, so it's a little bit faster way to draw them. And in most cases, we're not even going to draw things out like this. We just need to be able to understand what's happening so that when we look at ionic bonds, we know how this is going to work. And so here's ionic bonding. Ionic bonding is kind of we'll call it the middle school of bonding, where it's all about you. Okay, it's about what you can do to satisfy the octet rule. Okay, that's what we're trying to do here. And so we're taking things from other atoms to try to satisfy the octet rule. And so in this case, we have two atoms, lithium and hydrogen. Lithium has 3 electrons, 2 in the first shell, which fills it, and 1 in the second shell, which leaves it unsatisfied. Hydrogen over here has 1 in the outer shell. It is not full. And so what they want to do is they want to kind of work out an arrangement. Lithium over here, it can get rid of 1 electron, or it can add 7 to fill this outer shell to 8. It's a whole lot easier to get rid of 1 than it is to gain 7. So it will give its 1 to hydrogen. And so now I have lithium over here that has 2 electrons, and hydrogen that has 2 electrons. They're both full orbitals, and so they're both stable. Both satisfy the octet rule. The only problem now is I had 3 positive charges over here before, and I had 3 negatives, but now I only have 2. And so that's going to give this atom a charge of positive 1, because I have 1 more positive charge than I have negative charges. So I lost an electron and gained a charge. Okay? This is now called an ion. Okay? It's an atom that has a charge. My hydrogen over here had 1 positive, now it has 2 negatives, so it has a negative charge. And so this is a negative ion of hydrogen. Now, what do I know about things that have opposite charges? They're attracted to each other, and so they're going to come together and make a molecule. This would be one of the ways that a lot of things in the opposite ends of the periodic table, so that first column and the last column, they're going to tend to bond this way, where one atom is significantly stronger than the other one, so it steals the electron to make itself satisfy the octet rule. Okay, and so in class we'll practice this so that we understand it good, but just know ionic bonds, swap atoms from one side to the other so that we can have a charge so we can satisfy the octet rule, which creates a charge, and that holds those 2 atoms together. They're really strong and fairly hard, brittle. You look at table salts, pretty hard. So some very unique and useful qualities there. Okay, we'll check you back in a couple minutes for covalent bonding, and we'll see you then. Okay, bye.